Professor P.N. Rajama Memorial Lecture Series 2020, organized by the Department of Botany, Maharaja's College, Government Autonomous Ernakulam, in association with Kerala Academy of Sciences, Trivandrum. Let us begin the program with a prayer. I invite Ms. Srilakshmi K. of 2nd MSc Botany for the prayer song.
മന്ത്രം ജപിക്കുമ്പോൾ അറിവിൻകുമ്പോൾ നിരാശ്രയ ആസാദേ നിരതം ഞങ്ങളെ നിൻ കരുണാമൃത ധാര ചൊരിയൂ നിരാശ്രയരാക്കാതെ നിരതം ഞങ്ങളെ നിൻ കരുണാമൃത ധാര ചൊരിയൂ ഇരുളിന്റെ ഉള്ളിൽ നീലാവ് പോലെ ഈശ്വരാ നീ നിറയണമേ.
I kindly invite Professor Thomas Anthony, Head of the Department of Botany, Maharaja's College, to deliver the welcome address.
Good afternoon, one and all. Am I audible?
Yes, sir, you are.
So today we have the fourth lecture in the series of Professor P.N. Rajama Memorial Lecture Series. Professor P.N. Rajama was our former HOD and a faculty member of the department for 22 years. And so she passed away last year. So in commemoration of her, your dedicated service, actually we have started this series. And this is the fourth lecture. And the topic is interesting: remote sensing and digital image processing of satellite data. So as far as we bio people are concerned, when it comes to technology and other aspects related to it, we are far behind actually when compared to other people of physics, chemistry, or other science subjects. So this is an area actually we know today. We need to have an interdisciplinary approach whenever we study anything. So you need to have an idea of all biophysical instrumentation techniques in order to succeed in our fields. So this topic is a relevant one and actually is part of the syllabus of MSc. So that's why we actually plan to have this as a topic of the lecture series. So my job is to welcome all of you. So today we have in our midst, Dr. Shanit KM, the Vice President of Kerala Academy of Sciences. So this series was started, last month, and we started it in collaboration with Kerala Academy of Sciences. So we are quite happy that we got all support. Whatever we asked for, we have got all support from Kerala Academy of Sciences. And so Dr. Shanit M, Vice President of the Kerala Academy of Sciences, is here today to represent KAS. So, on behalf of the Department of Botany and Maharaja's College, I welcome you, sir.
Thank you.
Now, the resource person of the day, the keynote speaker, is Dr. Leena Abraham, Assistant Professor and Head of the Department of Botany, St. Thomas College, Kozhencherry. So I came to know from Dr. Jasila that her expertise is in this area. She did her PhD related to this topic. So I think we cannot have a better resource person for the topic than her. So I hope the students who hear the class today will be enriched immensely. So on behalf of the Department of Botany and IQAC Maharaja's College, I welcome you, ma'am.
Thank you, sir.
When we have participants, actually I had forwarded the messages, forwarded the information to several colleges and department heads. I think some of the students from other colleges, some of the teachers also from other colleges are there. So on behalf of the Department of Botany, Maharaja's College, I welcome all the faculty members who have gathered here as participants from other colleges and the students of other colleges and the students of our college as well. And last but not the least, I welcome all my my colleagues of the department, the program. And I really am immensely thankful to Santosh Varghese sir for providing us support, technical support related to YouTube streaming and all. So sir is also here. I welcome Santosh sir also to the program, and thank you once again. Thank you.
Thank you, sir. Today, we are extremely happy to have Dr. Shaneet M., Vice President, Kerala Academy of Sciences, for this special address. To formally introduce Dr. Shaneet M., I would like to invite Mrs. Shanti Vasudevan, Assistant Professor, Department of Botany, Maharaja's College.
Thank you, Sneha. I think I'm audible to all of you.
Yes, yes.
Okay, thank you. It's my pleasure to introduce Dr. Shaneet M. from Vikram Sarabhai Space Center, ISRO, Thiruvananthapuram. Dr. Shaneet took his MTech in Chemical Engineering from Government Engineering College, Thrissur. He obtained his MTech in Chemical Engineering from IIT Kanpur and PhD from IIT Delhi. He joined VSSC in 1997. Since then, he is working on electrochemical energy system for spacecraft application. In his initial years, he worked on the development and realization of battery cells for use in satellites. Currently, he is working on design and development of fuel cells and electrolysis system for space mission and various other applications of ISRO. He's also associated with production and supply of Li-ion cells for launch vehicle and satellites. He is project leader for fuel cell power system and deputy head of energy system division at Vikram Sarabhai Space Center, Thiruvananthapuram. Thank you. Welcome you, sir. Thank you.
Thank you very much.
I kindly invite Dr. Shaneet M. to deliver the special lecture.
Yeah, thank you, and good afternoon to all students, faculty members, maybe public, my colleagues from CAS, Kerala Academy of Science. Really happy to be part of this. Yet another great program at this time of pandemic. And I'm very happy that on two counts. One is we are discussing a very, very relevant topic. We otherwise generally don't really understand its importance, possibly in our daily life. And it's nice to have a program to discuss about that. And then second thing is we are giving tribute to one of the greatest academician and who has contributed immensely to the teaching as well as research. So I feel happy and feel privileged to be part of this. And as I said, it's a very important and relevant topic, and you're all eager to listen, including me, eager to listen to the science and technological details that our speaker is going to deliver. My role will be to maybe to give a kind of an introduction and provide a background. So let me to make it clear, my area of expertise is different. I'm working on a technology development area related to spacecrafts. However, due to the pioneering work my organization is doing, Indian Space Research Organization is doing, hopefully I'm here, and I can also talk about what my organization is working on and the background to that. Well, coming to the topic again, as we all know, we often don't give importance to this domain in our daily lives. We don't really understand or realize how far we are connected to this. But the point is, from using Google app for commuting or locating a place of choice on daily life, to the policy decisions on import export of food grains and agricultural products at national level. The geospatial science and technology have taken its place. So this has become so important to all walks of life. But if we look back, possibly the value of the perspective from a vantage point, probably humans were aware much early. Possibly this would have come from his ancestral, heritage as apes. He or she would have been familiar with that bird's eye view from over the trees, or maybe over a course of time, once he was grounded on two legs, maybe out of curiosity at times, and out of fear from predators, he would have climbed the trees and enjoyed or utilized the look from top. And of course, as hunter-gatherer, this would have benefited him unknowingly. He would have been able to locate the animals, or his search for food would have been more effective. And later on, as farmer, he would have more judiciously utilized this information, possibly from a tall tree or from up the hill. Certainly it would have benefited him to locating good places or even monitoring the crop. And if you look back again, the platforms they would have used, it's very interesting. Pigeons are said to have been used. Balloons have been used. Well, once we invented camera, certainly many platforms this way developed. And as we go into the records, it says maybe a more scientific a remote sensing activity. We can say that it would have begun when balloons started taking pictures of the ground using newly invented photo camera, probably since 1840s. And this probably we can consider as the first systematic remote sensing activity. But this aerial photography based reconnaissance or remote sensing really developed into a very important area during World War II. And suddenly, as any other technological element, this also got into a war scenario, and they used it for locating troops and also to understand their enemy's infrastructure. There is a famous photograph you can Google and find. It is in 1903. Probably you can see that cameras mounted on pigeons. You can see in web. Now, with the advent of satellites, probably the real remote sensing as a routine activity or an established segment would have started. With Sputnik launched in 1957 in October, satellites indeed emerged as a possible platform, and a repetitive scheduled remote sensing as an operational system for Earth observation got matured in 1970s, it record says, with instruments flown on Skylab, later on Space Shuttle and Landsat. This matured into a real profession. NASA's Landsat is that way a remarkable milestone in this. basically, it really, the pictures it sent really created a ripple among all over the world, and really it got into a commercial segment later on. And even radar imaging was used for war purposes, and later that also got into a civilian requirement. Later on in 1980s, several other sensors, we all talk about, when you say looking from top, we generally, our perception is to see indivisible light, the passive remote sensing. We all see the reflected light, sunlight. However, we learned that instead of depending on the visible light from sun, we can also beam the rays of our interest. Let it be microwave or infrared or thermal or maybe radio or even X-ray. We can get the information of our choice, and possibly we can later on combine them to generate much more valuable information about the systems that we are observing. And this resulted in several sophisticated sensors and space-based systems, and it really got into a very big activity all over the world. So many nations, so initially though it started in US, probably it spread into several other nations, including India. Though remote sensing turned out to be a kind of a real area of work during World War II, the actual naming of this activity, that remote sensing, probably started in 1950s by a person called Evelyn Pruitt, a geographer with US Naval Research. He is believed to have coined this word remote sensing. Now, let me just talk about the Indian space program, which I belong. Right from its inception, we were deeply rooted on the requirements of national development. ISRO's activities were practically a translation of the much famed words of Vikram Sarabhai into action, which said, I quote, "We must be second to none in the application of advanced technologies to the real problems of man and society." Now, it is now part of history that ISRO did pioneering work in taking cutting-edge geospatial technologies to the benefits of common man. Well, India has the largest civilian remote sensing satellite constellation in the world. India is on the top in that respect. It includes a thematic series of satellites supporting multitude of applications in the areas of land and water resources, cartography, and ocean and atmosphere. So, we can also look at some of the specific details. When we say Indian space program, the visible part of the program is always the spectacular launching of satellites, basically the rocket launches. And now rocket takes about few tens or 20 minutes into space. What really happening is a big system is starting to work. A satellite is a very big system which provides hundreds of services on the ground. It gets connected to various stations on the ground, and then several services start operating. We all know that we have communication, we have remote sensing, we have navigation, we have science payloads, and different kinds of satellites are there. And India too are having its different types of satellites. There are about 18 communication satellites. We have today about 23 remote sensing and 8 navigation satellites and about 3 science payloads. And it is not just about the satellites alone. We have a very vibrant constellation of satellites, as I mentioned, which includes ResourceSat, Cartosat, OceanSat, ReSat, and many others. There is a strong ground mechanism. There is an institutional framework. I'll be touching upon that, what we call as the NNRMS. And there are several enabling techniques and technologies on the ground. And we have a diversity of applications called natural resource management, infrastructure building, livelihood support, disaster management, reaching out to the community. Basically, we are addressing nation's developmental priorities. So our goals, Israel's goals have been on Earth observation, have been basically the periodic natural resource inventory, making of inventory, ocean state forecasting system, the disaster monitoring and mitigation, scientific understanding of the Earth system and its processes, and supporting our government for their developmental efforts, supporting the government, industry, and voluntary agencies in their development efforts for the nation. Now, if you look at the history of the remote sensing in India, it is credited to Professor Pishardi, who worked with C.V. Raman himself, later on moved to US and then came back and worked with Department of Space under Vikram Sarabhai on his invitation. And his pioneering work with regard to detecting coconut root wilt disease using aerial survey, used Soviet aircraft and American instruments, and he could very well demonstrate the utility of this work in India. And it is that time ISRO was getting formed, and then we were into remote sensing activity. And soon, under his able guidance, ISRO developed Bhaskara 1 and Bhaskara 2 with remote sensing payloads. That was our experimental activity. And then this success of this culminated in, that was in 79 and 81. And this culminated in our first operational remote sensing satellite called IRS, Indian Remote Sensing Satellite 1A. This is the beginning of the operational phase of Indian remote sensing activity, and this was in 1988. Since then, for the last 32 years, it has been a wonderful journey. We are now talking about Cartosat 3, before that Cartosat 2A, Oceansat, with several thematic satellites. We were having IRS satellites which covered an entire segment of remote sensing, and we gradually moved over to thematic satellites like ocean monitoring. We have Oceansat, various land and resource monitoring, we have ResourceSat, then various wide cartographic activity, mapping activity, we have Cartosat. So several thematic satellites have got into operation. And interestingly, as I said, each of these use a set of payloads which operate under different wavelength, not just the taking a photograph, which was there in the initial phase. We have several payloads operating under microwave, thermal, and so on, different segments. You will be getting into the science and technological elements of this and how well you can use this, especially I believe this is from a botany department. So the students can really appreciate when you really get into the talk by the speaker. Probably Madam will be touching upon the specifics of this. Let me just give a glimpse eye view of this. So we have, as I said, several satellites in, and there are two parameters you can look at. One is the spatial resolution. We have a few kilometers resolution to down to less than a kilometer. We can distinguish even less than that is possible. It is possible, and we also have the revisit. As you know, the remote sensing satellites orbit the Earth around the poles, so it goes from pole to pole. The advantage is that with the Earth orbiting on its axis, the movement of satellite on the orthogonal direction, it enables the satellite to cover the entire globe in a single day. It orbits around 15 times. So there is a revisit time for each satellite, and we have arranged satellite in such a way that it is even possible for certain satellite systems to take a revisit even in a matter of a day or even less than that. So that is a kind of achievement we have made, and this is going to make a very big impact in our ability to utilize this for any useful applications such as land mapping or resource management, even monitoring the crop and so on. So just to give an idea, ResourceSat 2 and 2A, you can look at, there is a 3-tier imaging from 56 meters to say less than 5.8 meters, and revisit capability ranges from 3 days to 11 days. And similarly, we have several satellites. So this is really adding value to our whole program. As I said, it doesn't stop with a simple launching of satellites and operating it. We have established a ground-based system to take care of it. As I said in the beginning, NNRMS, National Natural Resource Management System. So this is basically integrates the data and information from remote sensing into the national, regional, and local systems, like even panchayats and municipalities and corporations. Whatever they require, we are able to provide with the appropriate technical, managerial, and organizational linkages. So that is the purpose of NNRMS. So under this NNRMS planning committee, there are standing committees for which chairs are the secretaries of the Government of India from the departments like Agriculture and Soil, Water Resources, Bioresources, Environment, Geology and Mineral, Rural Department, Urban Development, Oceanography and Meteorology, Cartography, Training and Technology. So this is basically catering to addressing the national priorities such as food and water security, infrastructure development, environment and ecosystems, disaster management, weather and climate studies. You look at which almost all segments of the national development are covered under this. If you just take agriculture and soil, it can give the crop production forecast. You please understand the importance of this. So in say decades earlier, the availability of crop, or when a seeding is done, there has to be a land-based survey to understand the yield that you may get months later or in a year later, let it be wheat or rice or whatever. So now with a very precise satellite-based monitoring, you can have a prediction much earlier, and you can have a very accurate policies regarding import and export. You would have listened from media about these kind of decisions, and this is going to have a big impact on the pricing, availability, the stocking of the material, or even importing if there is a scarcity in case of any reason. So similarly, bioresources, this is giving us a very good idea about the forest coverage, deforestation, water availability, and so biodiversity and its impact. Everything we are able to make quick assessment very easily nowadays. So it also helps us in water resource management, urban development, and so on. So and it also helps us, and if you put it in a global way, it also helps us in disaster management. Now with so many disasters coming on us, we all know the need for predictions based on satellite systems. So this is a time when we really realize the need of satellite-based systems in our life. So there are, if you can go on talking about it, now there are several new Earth observation missions that are coming up. Basically, our focus is to ensure data continuity for operational applications. Hopefully, our main speaker may understand the importance of that. Meeting data requirements of the user community. We are not generating simply some data that we are capable, but we are trying to bridge the gap and trying to see what data the user community, the researchers or the implementation segment is really requiring. And also improvements in observations and data services, enabling R&D applications by providing newer observational capability, technology development and demonstration, newer technologies we would like to demonstrate, and collaboration to international cooperation. And there are many satellites coming up now to be launched, starting from Trishna, Nizar, ResourceSat Sampler, ResourceSat 3, ReSat, GSat, UshinSat, and HRSat. And these are all having very specific payloads to improve the existing capabilities and also enhance it to achieve greater precision and coverage. So apart from this, there are a lot of information services also attached to this. When you say there is a lot of data, terabytes of data that is getting streamed from satellites, one has to very carefully and intelligently integrate this, and then make it into useful products so that common people or even planners and various people in various walks of life, the researchers can make use of it for various requirements. So one such very important product is Bhuvan. We all are very familiar with Google Earth. and what the service it is providing. Bhuvan is one thing which is very similar to Google Earth, provided by ISRO's on satellites and information services, and it has more customized applications very suited to Indian conditions and Indian requirements. It holds about 60 terabytes of time series satellite data from 360 meters to 1 meter resolution, and it is interoperable 9,000 plus web services for about 14 thematic maps or base layers are available. As I said, you get a very different thematic data using different, let it be microwave or thermal, and then you overlay them and then try to generate more useful information about the object you are monitoring. Then there is a lot of open data anybody can access. There are millions of download by now. It gives timely disaster management information. Even during COVID time, very specific, region-specific useful information Bhuvan was able to provide. There are about 30 state portals under this Bhuvan, and so on. There are so many of them. One is visualization of Earth observation data and archival systems. This is something, the acronym is VEDAS. It is a platform to motivate young researchers and academia to showcase their spatio-temporal analytical skills using Indian Earth observation data and build geospatial applications. This is something very relevant to you all. And basic features of it is basically provides platform to research and training to academia, data visualization and graphical analysis, geoprocessing tools, integrating of web map services from various sources. And it can cover vegetation monitoring, new and renewable energy, urban sprawl information, hydrological application, cryosphere, and also air quality monitoring is possible through this. One can have value-added products through this. Another one is MOSDAC. It is Meteorological and Oceanographic Satellite Data Archival Center. This is a storehouse of meteorological and oceanographic data. One can register into it through a proper procedure and can make use of the data. We all are familiar with the weather data that are coming in our mobile phones, and these are captured from thousands of weather stations, very simple looking weather stations about few meters tall with about 10 sensors mounted on it. We have got couple of sensors in Trivandrum also, and also all over Kerala and all over India. And these are beaming data into satellite, and satellite is beaming it back for the entire country into a server under a Department of Space. And this data is now put under MOSDAC and it is disseminated to the users. So the mobile service people or any researcher can make use of it and can work on in their own way to build climate models or anything what they can look for. So these are several. These are basically the operational aspect of Earth observation or remote sensing, especially under the Indian Space Research Organization. And today, the array of Indian observation satellites with imaging capabilities in visible, infrared, thermal, and microwave regions of the electromagnetic spectrum, which is more familiar to you if I speak in this term, including hyperspectral sensors, have helped the country in realizing major operational applications, as I explained here. And the imaging sensors have been providing spatial resolution ranging from 1 kilometer better than 1 meter, and repeat observations, the temporal imaging from 22 days to every 15 minutes, and radiometric ranging from 7-bit to 12-bit, which is this has really significantly helped in several applications at national level. Well, this is what probably I can provide as an introductory material for this special session on remote sensing. And I hope our speaker will take us into the nuances of the technological and scientific elements of the remote sensing activity. Again, let me thank you all for giving me this opportunity, and I wish that this program will be really useful for all of you who have joined in this program. Thanks again for giving me this opportunity. Thank you, one and all.
Thank you, sir. Thank you for your valuable information. It was indeed a privilege to have you. Thank you. We feel profusely elated to have with us Dr. Leena Abraham, Assistant Professor and first person for the day. I now kindly request Dr. Stephen Sequeira, Assistant Professor, Department of Botany, Maharaja's College, to introduce the resource person for us.
Thank you, Sneha. Am I audible?
Yes, sir.
Good afternoon, Anna and all. It's a great pleasure to introduce Dr. Leena Abraham, who did her doctoral degree from the Maharaja Sayajirao University of Baroda, Vadodara, Gujarat, on the topic Impact Assessment of Joint Forest Management Activities through Remote Sensing Technique. She is also a gold medal winner in MSc and BSc from the same university. Currently, she is working as Assistant Professor and Head of the Department of Botany, St. Thomas College, Kozhencherry, Pathanamthitta, since 2014. Before joining St. Thomas College, Dr. Leena served as Senior Associate Professor at IQAC Institute, Andheri, Mumbai, for 1 year. Besides this, she's also worked as a faculty in institutions like N.V. Patel College of Pure and Applied Sciences, Vallabha Vidyanagar, Gujarat, Department of Botany, the Maharaja Sayajirao University of Baroda, and Kendriya Vidyalaya, Vadodara. Dr. Leena has secured many awards during her course of study and also as a teacher. To mention some of these, Akash Guru Award for Outstanding Performance in Teaching at Akash Institute for 2013, Vaidya Narayana Rao Hardikar Gold Medal for MSc, Professor A.R. Chauhan Memorial Fund Prize for securing highest number of marks in MSc Botany, Dr. M.S. Patel Postgraduate Scholarship for securing highest number of marks in MSc Previous, Postgraduate Merit Scholarship for securing highest number of marks in BSc, Dr. V.G. Padak Gold Medal for BSc, Dr. M.S. Patel Prize for securing highest number of marks in BSc Botany, and Professor A.R. Chauhan Memorial Prize for securing highest number of marks in Botany. Professor Leena, she has completed 2 research projects during these years, sponsored by Kerala State Council for Science, Technology and Environment, Government of Kerala, and Gujarat Council on Science and Technology, Gandhinagar, Gujarat. To her credit, Dr. Leena has published more than 12 research papers in various national and international journals and co-authored 5 books on various topics in botany. Dr. Leena has delivered many invited lectures in colleges and schools on various topics. She's a life member in Indian Society of Remote Sensing, Dehradun, and Indian Society of Geomatics, Indian Space Research Organization, Ahmedabad. Apart from her teaching and research activities, Dr. Leena has she was very active in extracurricular activities too. A state-level basketball player and an award winner in many drawing competitions. Moreover, she's a Rajya Puraskar guide, a highest award in state-level by the Scouts and Guides. So our research person is she is multi-talented in many ways. Today, Dr. Leena Abraham will be delivering a lecture on remote sensing and digital image process. On behalf of Department of Botany and IQAC Maharaja College and Kerala Academy of Science, I welcome Dr. Leena Abraham for the presentation. Thank you.
Thank you, sir. I cordially welcome Dr. Leena Abraham to deliver the keynote address.
Thank you so much, Neha. Thank you so much, Stephen, sir. Actually, I was feeling so much embarrassed. I understand the need that we need to shortcut the biodata a lot before sending it anywhere. Thank you, sir. So much of elaborate introduction, what not at all needed. but I appreciate. Thank you so much. I'm a very humble person, and as all of you who are in this online platform, I am also a learner, not a very great resource person or something like that. My aim for today's class is just to share my experience with remote sensing, what all I have gained knowledge about it. As Shatithan sir had very clearly said that there is a plethora of knowledge regarding remote sensing. In 1 hour's times, it will be very difficult for me to curtail everything, but still I'll try my level best. Am I audible to all?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Okay. So at the onset, let me congratulate all the organizers. Thomas Anthony sir, head Department of Botany, Maharaja's College. Dr. Jasila F. and Dr. Stephen Sikoria, coordinators of this program, for organizing Professor P.N. Rajamma Memorial Lecture Series. I think this is 4th in the sequel. And remaining 3 I have attended. It has always related to upcoming science, and the topics were always very interesting and very lucrative. So I congratulate all the organizers. I especially thank Dr. Shaneet M., Vice President, Kerala Academy of Sciences. Sir has given in a capsule format the entire thing about remote sensing and ISRO. And as I would say, as Sir has very rightly said, in the welcome address, Thomas Anthony Sir just said that botany students are not very much well aware about the technology. Yes, that is true, Sir. So this is a time, after listening to Sir's talk also, we should be proud that ISRO is doing a commendable work. And I think it is 5th in the position in the world for its notable contribution in the space technology. So let me proceed on to my class, and it will be, I'll be as I am told by Dr. Jasila that many of the students are from UG background. You have PG students also. I'll be talking about very basic things. From very basic things, I'll try to give you a glimpse exactly what all is done in remote sensing. It won't be possible to give an entire thing, but I'll just give you an overview. Okay, so that you understand what is the technology all about. So let me just present the slide. Is the slide visible?
Yes, ma'am.
Okay, okay. Anything, if I exceed the time, just I will request all the organizers just to hint me. Okay, and anywhere I need to stop, please let me know. Okay.
Sure, ma'am.
So now remote sensing and digital image processing of satellite data. That is what I'm going to talk today. I would request all the participants, anybody of you or those who of you, one of you have heard this term remote sensing. Can you just enter in your chat box? I would be happy to know what all you know about this. Just your information. If you know five topics, 5 basic lines about remote sensing. If you can enter into your chat box whether you know anything about remote sensing. Just 5 sentences if you know, just put in yes or no. I appreciate some of you just to enter into chat box. I'm waiting for answers. Anybody? Anything? Whether you know about it? I'm not getting a single yes. That means nobody knows anything about remote sensing except our distinguished guests. Okay, Ashwini has said yes. Okay, something she knows. Okay, anybody else? 5 sentences you know about remote sensing, you just put in yes. Okay, I'm not getting any further answers, I think. Okay, so I need to add a knowledge about what exactly you know about it. Okay, so I'll start about from the very basic thing. Now, when we talk about remote sensing, Now, my question, can we study any object without coming in direct physical contact with an object? That means if you want to take a section of a stem, or if you want to study the morphology of a leaf, right? You need to take the leaf, you need to pluck the leaf, and you want to study it, or you want to take a section of it and observe it under the microscope, right? So for studying any object, you need to come in close physical contact with that object under study. Now, there is a technique or there is a tool wherein you can study about an object, but still you don't need to touch that object. So that subject or that technique is remote sensing. I would like to specify here that remote sensing is not a subject. Okay, it is only a tool or a technique. As a definition, this is a very simple definition of remote sensing. Remote sensing is a tool or a technique for studying an object without coming in direct physical contact with the object under study. You're trying to study about an object, you're trying to gather in information about an object, but you are not physically touching that object under study. This technique is called as remote sensing. Obviously, we also can do some sort of a remote sensing. How? Our eyes, our body are given, everybody is given with two eyes, right? So we can, with our eyes, there's a plant, potted plant in front of on my table. I'm not touching that plant, but without touching that plant, I can say the pot color is white in color, the leaves are variegated, which is there on my table. I'm not touching it. So what is your eyes? Your eyes are acting as a sensor, which are recording the information. Similarly, for remote sensing, if you want to study something, you need a recording device, and that recording device is known as a sensor. Sensors in remote sensing are placed on platforms. Okay, so what exactly is a sensor? Sensor is a recording device. Okay, and this recording device will be placed on some platform. These platform can either be on the ground, it can be in the air, or it can be in the space. With the diagram, I'll explain it. For example, this is a ground-borne platform. This aircraft, sir had talked about this airborne platform, and this satellite is a space-borne platform. All these are the platforms. Platforms for what? For carrying the sensor. The picture which I have inset over here, that is an actual picture of a sensor. Okay, so all the platforms are here to carry the sensor. And what does a sensor do? Sensor is a recording device. It is the one which will record the information about any object which you want to study or you are interested to study. Okay. Now, on what principle does remote sensing work? So we all are aware about sunlight is a major source of electromagnetic radiations. Okay, all electromagnetic radiations are from the sun. Those electromagnetic radiation is having smallest wavelength X-ray to the longest wavelength. You are having the entire spectrum is there. Now, in this entire spectrum, our sensor, which is our eye, is capable to see only in a narrow band or a narrow region, which is called as a visible region, right? That is around 400 nanometer to 700 nanometer. So our eyes are having the capacity to see the object only in this small range. But a sensor of remote sensing or a recording device of remote sensing can cover the entire electromagnetic spectrum. It can take information or it can collect information from the entire electromagnetic spectrum, though these spectrums are divided into various bands or various atmospheric windows. I won't go into details of what are atmospheric windows or bands because it won't limit within this topic. Okay, so now let us see how does a recording device, which is a sensor, is collecting the information. How does data is collected? As I just said, sun is a major source of all electromagnetic radiations or the solar light. This sunlight is falling on various objects on the earth, whether it is a forest, water, grass, bare soil, or a built-up area. Now, every single object on which the solar radiations are falling, based on its physical and chemical properties, will absorb some radiations, it will reflect some radiation, it will transmit some radiation. The net radiations will be received by the sensor which is placed on a satellite. Okay, this is a satellite, and inside which you are having the recording device, the sensor, which will capture all these radiations. Okay, now these radiations or these net radiations which are captured by the sensor which is placed in the satellite, those radiations become a valuable source of information, or those radiations become a valuable data for interpretation. Now, as I just said, how it becomes so much valuable, that is reason because every object, as I said earlier, based upon its physical and chemical properties, based upon its internal structure, external morphology, it will reflect radiations in a particular pattern. For example, here you can see the reflectance pattern of a soil and water is exactly opposite to each other. More or less, they are in a not having too much of peaks and valleys. But when you look at a vegetation, we being botanists, we are more interested in the vegetation part. There are more of peaks and valleys, peaks and valleys. Okay, so this is a reflectance pattern of different object, and any object on the earth will have a specific reflectance pattern. It is so much specific that many a times this reflectance pattern is called as a spectral signature. Why it is called as a spectral signature? The reason it is very unique. Every vegetation will have a specific spectral signature which will be different from soil, it will be different from water, it will be different from wood, it will be different from metal, it will be different from gravel, it will be different from road. So every object will have its unique spectral reflectance curve, which is better called as a spectral signature because it is highly unique in nature. Now, we being botanists, we are more interested in the vegetation part. So I am going to deal with vegetational reflectance pattern in more detail. I hope the slide is clear. You can see earlier slide, reflectance pattern is that of the vegetation. Okay, in that the reflectance is from the visible region, it is from the near infrared region and the short wave infrared. These are the major wavelength regions in which vegetation will reflect the maximum. And the reflectance in this region, visible region, is controlled or it is determined by the leaf pigments. As a botanist, we know that plants are having different pigment composition, chlorophyll A, B, C, D, and also carotenoids, xanthophylls. They are the leaf pigments. They are the one which control the reflectance pattern of a vegetation from the visible region. And every cell is having, every plant is having as internal anatomical details, a different cell structure. You may be having knowing about C3 plants, C4 plants, Kran's anatomy. Internally, these plants are different from one another, right? So the cell structure, it is having more of parenchyma tissue, it is having less of sclerenchymatous tissue, it is more of a hydrophytic plant, it is more of a xerophytic plant. The internal cell structure or the internal anatomy will change. The internal anatomy of a plant is the one which controls the reflectance pattern in the near infrared region. Similarly, water content, as we know, all living organisms, whether it is a plant or an animal, they are having 90% of water. The water content of a plant will be controlling the reflectance pattern in the short wave infrared. So visible region which is visible to our eye, that is a very small narrow range and the reflectance is very less. But maximum reflectance can be seen in near infrared and middle infrared region by a vegetation or by any plant body. Okay, I suppose this is clear. Now moving forward, Now, how is this data, what I just talked about? So, changes in amount and properties of EMR become, upon detection by a sensor, a valuable source of data for interpreting important information on shape, size, physical and chemical properties. I just go back to what are the slides I just said. What we had talked about, sun is a major source of solar radiation, EMR, the electromagnetic radiation which fall on the ground or on the earth. Every object based upon its typical physical and chemical properties, they will be reflecting some radiations that which are captured by the recording device which is there in the sensor, that becomes a valuable information. Okay, and that valuable information is a spectral signature of every single object. Now, though that data which is captured by the sensor can either be displayed in a digital format or a pictorial format. Okay, so the data which is generated can either be in the form of digits, numbers, or it can be form of a picture, okay, or an image. The data captured by a sensor in the digital form is more or less called as an image. So data is there with the sensor. That sensor is then sending the data to the earth. For example, in for us in India, we are downloading all the data at NRSA, and National Remote Sensing Agency, that is in Hyderabad. All the data is getting downloaded there. Okay, so that data can be represented in a digital format in a CD, or it can be converted into a picture which is visible. Now let us see how a satellite picture or an image looks like. Before starting with the satellite data or an image or a pictorial form of an image, I would just bring your attention back to that. Our eye has a limitation of seeing only in visible region. But the eye of a remote sensing, that is a sensor, can cover the entire electromagnetic spectrum. But our eye cannot see any radiations which is in infrared region. That is a limitation of our eye. And we want the data in a visible form, in a picture form. In order to see the radiations which are not visible by human eye, we need to give, the scientists then had decided to give a false color. For example, any reflectance in the infrared region is given, allocated a false color. The false color is red. Similarly, any reflectance in the red region will be given a false color of green. And any reflectance in the green region will be given a false color blue, so that these colors are visible to our human eye and we can see the satellite image. So now, which the picture which is presented below, this is completely red in region. That means this satellite image is reflecting in the infrared region, which has been given a false color of red, and hence the entire image looks red in color. Okay. Similarly, the reflectance in the red region is given a false color, that is green. Can you see? And another image is overlaid on it. Similarly, all the reflectance on the green region were given a false color of blue. Look at the third image. And all these three images are overlaid one above the other, and you are getting a final satellite data or a final image. It is also called as a final imagery. You can say anything. Now, as a remote sensing analyst or people like us, our duty is to analyze this data. What does it indicate? And where you want to use it. Okay. Same satellite data can be used for varied applications. It can be used in the agriculture, it can be used in the forest, it can be used for water resource management, it can be used for urban planning, it can be used for road and rail network understanding, contour mapping, disaster mitigation, any, you name any application, the same data can be used. Okay, so we are having at present what is there in our hand. We are having a satellite data. This is an imagery, and this satellite data we want to use it. Now the question arises: what you want to use it for? What you want to study it for? So, in order to, my aim for this talk is to make you understand how this entire technique or the tool works on. So, I am trying to take one case study, or I will try that how to approach a satellite data, how to use a satellite data. For that, and how you can exploit the satellite data, coming to the next point of my satellite image processing, or how you can do digital image processing of the satellite data. So after getting data downloaded from the satellite, we have downloaded the data which you have in a picture format, which I just showed you. Now that picture which is there in your hand, how to use it? How an application scientist can use the data. For what? For which? For making you understand that, I have taken a case study. What is a case study? The aim is to do a forest density classification using satellite data by attempting various digital enhancement techniques. Okay. If you don't know what is forest density classification, I just would draw your attention to forest density classes are based upon the crown density, or how much area the forest is occupying on the ground. So any area which is having a crown density greater than 40%, such a forest will be called as a dense forest. From 30%, it will be called as an open forest. Less than 10%, it will be called as a degraded forest. So what is the aim? Aim is to, in our study area, we want to classify the forest which is there in these 3 density classes. Okay, the aim is clear. Now, for getting the information, we first want to understand which satellite we will use. In that satellite, which sensor we want to use. In that sensor, which band we want to use. How many times you want to use. And how you can manipulate a basic original satellite data with various enhancement technique, so that maximum information can be generated from the satellite data. How you can, I won't say manipulate, manipulation will be a wrong word, how you can deal with the satellite data in such a manner that maximum information can be gathered. That is called as digital enhancement techniques. Okay, moving forward. So as I said, for doing this, Satyachan sir has already talked about various IRS satellite. For the aim which I had selected, IRS 1C 1D will be fine as satellite. It is having 3 sensors, LIS3, PAN and WIFS. For understanding which sensor to use, you need to understand, sir had talked about spatial resolution. If you remember, every satellite sensor will have a different spatial resolution. Spatial resolution is something, resolution of your microscope. Similarly, what do you mean by resolution of a microscope? Which is the smallest object you can see inside the microscope. Similarly, spatial resolution of a sensor is the smallest object which can be captured by the sensor of a satellite. For example, any object greater than 23.5 meter will be captured by sensor LIS3. Any object which is greater than 5.8 meters will be captured by sensor PAN. And for WIFS, it is 188 meters. Every sensor will have its own spatial resolution, the smallest object which we can see. For a forest, what was our aim? Our aim is to understand the forest and forest density classification. For that, you can use any of the sensor, but you are not here to count the trees. If you are supposed to there to count the trees, PAN data would have been better. Okay, but you want to understand a forest. For that, 188 meters is also not suitable. 5.8 meter is also not suitable. But 23.5 meter resolution is okay. So LIS3 data will be considered to be better data, which having a repeativity. Sir had in his initial talk, he talked about repeativity, which is also called as temporal resolution, or after how many days the satellite will be or the sensor will capture the data of the same area. That is what you mean by repeativity. So for the aim, what we have selected, list 3 data, which is having 23.5 meter resolution and which is having a repeativity of 24 days will be fine enough to study it. Also, list 3 data is having 4 bands. 4 band, every sensor is having a bandwidth. What is a bandwidth? This is the wavelength on which it is capturing the information. In the preceding slides, which I talked about, I had overlapped the slides, if you remember. One picture red, then blue, then green. They were the band lengths on which the sensor is capturing the information. Because we are studying forest, which is in vegetation, these 3 bands, that is red, infrared, and middle infrared, will be better for us. We don't need reflectance pattern because of 0.52 to 0.59. Because vegetation reflects very less in the green region. So this is not a beneficial band for us. These 3 are beneficial band. So hereby we have decided satellite, the sensor, and the band length. Okay. Okay. Now how to proceed with the methodology or how to move forward with the analysis. If you're doing remote sensing technology can get a major if we use one more technology along with it, that is GIS, Geographical Information System. It is a bit because of the limitation of the time, I cannot go into major details about GIS, but I can just tell it will gives us, it's a data storing thing. Data can be stored, information can be stored. For example, in remote sensing, we can map a village, but adding attributes to the village, what is the name of the village, how much is the male population, female population, what is the cattle population, all these attributes being added to a simple village information is done by GIS. This is a very, very basic thing. Don't think that GIS definition falls in it, because considering the UG students, I have just said this much. Okay, so how are we going to do the forest density classification? For that, we need a SOI map, which is called a Survey of India map. What is an SOI map? That is a reference map. Survey of India is producing continuously maps based upon detailed, extensive field work. These maps are produced by actually visiting the field. On that basis, you will create a spatial framework. Okay, a framework based upon various themes. That the various themes are, you are making a base map for forest boundary. You're making another layer of base map, mapping only the roads and the rail. You are making third one based upon the streams, and next based upon the settlement. These are the various themes on which a base map is created. And from where the base map is created? The base map is created from Survey of India maps. You are actually tracing it. Ningal record a book trace cheyatillyo, aduvole oru tracing work. Okay, trace nennu cheyan paadilla, pashengil here you are doing a tracing work. Now this is your base map. Now on these base maps, this becomes your benchmark. Now you're coming to your satellite data. Now satellite data is not understanding what are the political borders. You need to take a study area. So what is your study of area? You need to subset, or you need to cookie cut it. Cookie cut it from the entire satellite data. നിങ്ങൾക്ക് വേണ്ടിയ അല്ലെങ്കിൽ നിങ്ങൾക്ക് ആവശ്യമുള്ള region മാത്രം ആ satellite data എന്ന് മുറിച്ചെടുക്കണം. That is called as a subsetting the study area. Then you are doing image rectification, digital enhancement, layer stacking. ഈ 3 കാര്യങ്ങൾ നിങ്ങൾക്ക് അറിയത്തില്ല. നെക്സ്റ്റ് സ്ലൈഡിൽ ഞാൻ പറയുന്നുണ്ട്. Then finally enhance the satellite image will be subjected to interpretation. That is what a remote sensing analyst do. Either you can go for digital interpretation or you can go for visual interpretation. Finally, without having an extensive field work, you can do a forest density classification. Our aim adarunnu. Let me remind you what was our aim. In a study area, we want to do forest density classification. Okay, so this is the basic outline methodology, how we will approach the subject. These are the things which I just told about the forest classification. Thematic maps we generate thematic map parna evidoke a study area etra gramangal undu etra cities undu evidoke a study area de forest inde boundary etra railum road inde network eda idellam nammade basic information. These are the benchmark on which our forest density classification will be done. Okay. In the methodology flowchart, I talked about image enhancement. Just have a look at the picture, the slide. This was the original image or an imagery you received from NRSA. Okay, this is what I received. എനിക്ക് NRSA ഞാൻ മേടിച്ച data ഇതാ. ഇങ്ങനായിരുന്നു ആ original data ഇങ്ങനായിരുന്നു. Okay, NRSA is providing this data. Now, this data is basic. Excuse me. Sorry for the disturbance. So this is the basic data which I purchased from NRSA, which is called as original satellite data or the original imagery. Now, you will submit it to various image enhancement technique which is already available in the software. Either you can do for linear stretch, Gaussian stretch, SB stretch, gamma stretch, or histogram equalization. There are various other image enhancement technique, but for my work, I found that histogram equation was the best result. Because you can see the clarity of the image, any layman can understand it. This image has much greater clarity and greater features which are visible as compared to all the other enhancement techniques. So I finalized that my original image, I will subject to histogram equalization. After trying all the other methods, I shortlisted to one technique, that is histogram equalization, which gave me maximum contrast for my forest density classification. Now, what next? Okay, so you have already selected histogram equalization was considered to be better. Now you can still enhance the image further and further. How to enhance the image? ആദ്യം ഞാൻ പറഞ്ഞപ്പോൾ 3 ബാൻഡ് നമ്മൾ സെലക്ട് ചെയ്ത് ഞാൻ നിങ്ങൾക്ക് ഓർമ്മയുണ്ടോ? I said that 3 band data. List 3 data is a 3. It is basically 4 band, but നമുക്കിപ്പോൾ 3 band വേണ്ടി. So the 3 band data is there. Every single band information you can visualize it separately on the software. This is band 1, band 2, band 3. You can see it is a picture is the same. I mean to say geographical location, you could make out that geographical location is the same. ഈ റിവറിനെ കണ്ടാൽ നിങ്ങൾക്ക് മനസ്സിലാവും എല്ലാ പിക്ചറുടെ ലൊക്കേഷൻ സെയിം ആണ്. അപ്പോൾ ഈ 3 ബാൻഡിൽ ഏറ്റവും നല്ല ഇൻഫർമേഷൻ or the best information you can get is from band 3. So I selected band 3. Then principal component analysis, this is PC2, 1 and 3. This is also an enhancement technique in which better result was seen in PC1. Another method of image enhancement is band ratioing, which is called as you ratio band red region with band IR region, infrared region, you get such image. Also, there is another band ratioing which is called as NDVI, normalized difference vegetation index, in which red is you minus red image with my IR and divided by IR plus R plus IR. Okay, so this is a band ratio. You are not doing anything manually, you are just telling the software to do it. So NDVI amount in relation to both the band ratioing techniques, I got better results in NDVI. So I took band 3, I took principal component analysis 1, then I took band ratioing NDVI. These 3 images which were received were layered one above the other. This technique is called as layer stacking. You are putting one above the other. As a sandwich, you are keeping one bread above the other. Similarly, these 3 layers are kept one above the other to get the final image. Now, this image is ready to be analyzed by any remote sensing analyst for the study. Now, this data is having maximum information. This data is having maximum contrast for the purpose for which I want to use, that is forest density classification. So, in the study area which I had selected, our aim was what? To forest density classification into close to forest, open forest, and degraded forest. But when we visited the forest area, we could see that there was a fourth category, that is sparse tree cover with agriculture. That means the villagers in those region are illegally encroaching the forest area and they are cultivating inside the forest area. So this was a new category named as sparse tree cover with agriculture. So these were the 4 forest classes, and another 4 non-forest classes which was selected was settlement, canal was there was a well-developed river, and then obvious agriculture. So these are the 8 classes of the study area which I had selected. Now, what next is done is this 8 classification or 8 areas which were selected are selected and told to the computer that based upon this 8 different criteria, classify the study area. This type of a classification is called as digital interpretation. If you remember in the methodology flowchart, I talked about there are digital interpretation. This digital interpretation is also called as supervised classification. This entire study area has been divided into various forest density classes and also new categories such as sparse tree cover with agriculture, canal, wasteland, etc. So this entire classification, you can see the color codes. As a layman, you can just understand that dark green is all close to forest, and red region is all degraded forest, and blue regions are all open forest. This was done, completely done by the computer. It is matter of only 2 to 3 days to complete the entire study area or entire district. You can classify it based on digital interpretation within minimum time. But they have a problem. What is the problem? Look at the overall classification accuracy. The overall classification accuracy was found to be less, that is 74.29%. This is somewhat less. You cannot accept this classification system. Now, what is the reason that this classification reason so reduced? So, trying to understand what was the reason for lesser classification accuracy, you have to go and check on ground. So what I found it is, you had seen earlier, I had shown a photograph in which I talked about the locals over there are encroaching into the forest area and doing agriculture practices. Those category is called as a sparse tree cover with agriculture. Okay, in that there is a mixing of characters. Why? Because agriculture is also vegetation, forest is also vegetation. So agriculture is also a plant, forest also has plant, and spectral signature of vegetation is more or less same. So there is a mixing of overlapping of characters. These plots show that there is a mixing of the category, that is a degraded forest and the sparse tree covered with agriculture and also agriculture. So these 3 categories, there is an intermixing. So computer is not able to understand which category is in agriculture, which category is a degraded forest, or which category should be given as a sparse tree cover with agriculture. You need to separate it. Now, computer, when it is doing a digital interpretation on its own, it is not able to separate it, and there is a mixing of classes. In order to overcome this mixing of classes, we had to go for next type of interpretation, that is visual interpretation, on-screen visual interpretation. What do you mean by on-screen visual interpretation? Means നിങ്ങളുടെ റെക്കോർഡ് വരയ്ക്കത്തില്ലേ, ഓക്കെ, നിങ്ങളുടെ പേപ്പറില്ല നിങ്ങൾ റെക്കോർഡ് വരയ്ക്കുന്നത്, അതേ കാര്യം നമ്മൾ കമ്പ്യൂട്ടറിൽ വരയ്ക്കുന്നതിന് ഓൺ സ്ക്രീൻ വിഷ്വൽ ഇന്റർപ്രിട്ടേഷൻ എന്ന് പറയുന്നത്. സിമ്പിൾ കാര്യമാണ്, ബട്ട് ആസ് എ റിമോട്ട് സെൻസിങ് അനലിസ്റ്റ് യു നീഡ് ടു ഡെവലപ്പ് എൻ ഇന്റർപ്രിട്ടേഷൻ കീ based on which is the tone, color, size, what shape, what is the texture, what is the pattern, location, association, and based upon the interpretation key which is developed by a remote sensing analyst, the on-screen visual interpretation will be done. So I had done that. So this is the interpretation key. For example, if you get some color texture like this, that means I will label it as dense forest. Actually, you have to mouse വെച്ചിട്ട് വരയ്ക്കണം, അതിന് ബോർഡർ വരച്ചിട്ട് അതിനെ ലേബൽ ചെയ്യണം, the dense forest ആണ്. ഇങ്ങനെ പിങ്കിഷ് കണ്ട ഓപ്പൺ ഫോറസ്റ്റ്, greenish something കണ്ടെങ്കിൽ degraded forest. This category was the one which created problem for the digital interpretation. Sparse tree cover with agriculture. Then agriculture, then canal and river. ഇങ്ങനെ ഒരു ടേബിൾ ഉണ്ടാക്കി ഒരു ഇന്റർപ്രിട്ടേഷൻ കീ ഉണ്ടാക്കിയിട്ട് വേണം ഒരു റിമോട്ട് സെൻസിങ് അനലിസ്റ്റ് ആക്ച്വലി ഡേറ്റ, സാറ്റലൈറ്റ് ഡേറ്റ ആയിട്ട് ഇരുന്ന് ഇന്റർപ്രറ്റ് ചെയ്യുക. ഇന്റർപ്രറ്റ് ചെയ്ത് കഴിഞ്ഞിട്ട് ഫൈനൽ റിസൾട്ട് വാട്ട് യു ഗെറ്റ് ഇസ് ദിസ്. ഓക്കെ, അപ്പൊ നിങ്ങൾ സൂക്ഷിച്ചു നോക്കിയാൽ യു ക്യാൻ സീ ദ സ്മോൾ പോളിഗോൺസ്. ഓക്കെ, this is a degraded forest, this is an red one is an open forest. This actually I have drawn it with my hand, and this is small thing which is there on your computer screen or your mobile screen, but actually it is a size of a 10 A3 size paper. നിങ്ങളുടെ ചാർട്ട് പേപ്പർ 10 ചാർട്ട് പേപ്പറുടെ സൈസിലുള്ളതാ ഇത്രയും കാണുന്നു. And what was the success? The overall classification accuracy was 93.1, which was very good. Anything above 90% is acceptable. So what was the drawback of digital interpretation was overcome by visual interpretation, and this is not as that simple as it is seen. Digital interpretation, we can say that നമുക്ക് ചെയ്യാൻ ഒരു 2-3 ദിവസം മതി. എന്നാ ഇതെന്റെ ഒരു താലൂക്കയുടെ മാത്രം, ഒരു താലൂക്ക് ഏരിയയുടെ മാത്രം ഫോറസ്റ്റ് ഡെൻസിറ്റി ക്ലാസിഫിക്കേഷൻ will take around 6 months. Okay, you can imagine the time duration. But yes, after which overall classification accuracy was 93.1. Okay, so this, and what was our aim? We want to get area under each forest classes. How much was the area? So closed forest, open forest, degraded forest, in ellathilum how much is the area statistics was easily calculated by remote sensing analysis. So what was our aim? We want to do forest density classification. Yes, we could do a forest density classification. These are the 3 forest density classes. In addition, a new class was discovered, sparse tree cover with agriculture. That it has a mixing of pixels between agriculture and degraded forest. But still, through on-screen visual interpretation, it was able to demarcate all this. So ഞാൻ ഒരു aim വെച്ചിട്ടാ തുടങ്ങിയ. If you remember, I started with the aim. I want to do forest density classification through remote sensing technique by exposing the data, satellite data to various enhancement techniques, histogram equalization, and then layer stacking, then principal component analysis, band ratioing. ഇങ്ങനെ പല രീതിയിലുള്ള enhancement technique use ചെയ്തിട്ട് finally you got the best satellite data which is suitable for the application which I want, that is forest density classification. With this one case study, I hope it is clear to you that how a remote sensing analyst work on various applications. So this was the application that is forest density classification we had done. We can also do forest monitoring. That means what all changes in the forest density classes are going on. We can even detect forest fire by remote sensing. We can also do change detection, that encroachment is there or not. What is the changes which is happening in the forest? Forest തന്നെ ഒരുപാട് application remote sensing and GIS is having. In addition to that, not just in forestry, various other fields remote sensing can be used. Another one area is agriculture. These are all satellite data and from sources NRSA. Because it is not an offline regular platform, doubt that agriculture is also vegetation and forest is also vegetation. How can we demarcate them both? Now, as a remote sensing analyst, just pay attention to where my cursor is moving. This is an agricultural area. Okay. How I can tell like that? Because of the geometric patterns it follows. Okay. Agricultural analysis or the crop prediction can be found out. How much area under paddy cultivation, how much area under, for example, rubber cultivation. In Kerala, the major crop rubber. All this can be analyzed. This is another problematic area of agriculture, which is salt affected area, saline areas. Next slide agriculture, forest and the demarcation. Just have a look at this slide. Patch. This is about cotton. Cotton the crop. Okay. And 2 is paddy. And 3 is bubble. Bubble is a type of a fodder shrub along a small tree. This is from area where this is grown as a fodder for. It is considered, this leaves of these trees are considered to increase the milk production in cattle. Fourth is forest. Can you analyze? There's a geometric pattern over here and here. Box, box, box pattern. And even geometric patterns illa. It is red in color. It is continuous. So continuous patterns are those of forest and geometric patterns are those of agriculture. Angane, forest and agriculture, even though they both are vegetation, both are having typical peak and valley spectral signature pattern. Still, based upon the geometric patterns, you can identify whether it is an agriculture or a forest. Then land use, land cover mapping. This is a common term. This is a part of Mumbai. I was been here earlier before I came to Kerala. Here you can make out which all. This is a densely populated area. Okay, so this is a harbor. Ivda ships on the land. So same data you can use for many applications for various. We can understand which is the urban layout. You can also understand the road network, etc. Another application is urban layout. You can make out this is a Bhubaneswar city, Orissa. You can make out these are the roads. Okay, the road. Okay, this is some stadium or something like that. These are the buildings. Okay, Ipparthum where a photo ittittundu. You can, if you observe closely, can you make out this buildings? Can you see the shadow of those buildings? Okay, this look more or less like a photograph. Okay, because the satellite image is taken, photograph is taken from this side. In a 3-dimensional photography that comes more or less in your PG syllabus photogrammetry. Photogrammetry more or less a 3D images we make so that even we can understand the height of each buildings. Oro building the height analyze. Photogrammetry is a different field in itself. but that also comes. Adil engana cheyyana oru just overview parayava. You can taking the picture, satellite will take picture from this side and this side, and both the sides on eduthittu it will create a stereo image. For example, നമ്മുടെ ശരീരത്തിൽ രണ്ട് കണ്ണാ, okay, both eyes are independently seeing and both the images are overlapping one above the other to make a stereo image. അതുകൊണ്ടാ നമ്മുടെ മുമ്പിൽ നമ്മൾ കാണുന്ന എല്ലാ ഒബ്ജക്റ്റിന് ഒരു 3-dimensional വ്യൂ ഉണ്ട്. അതുപോലെ തന്നെ ആ സെയിം പ്രിൻസിപ്പൽ റിമോട്ട് സെൻസിംഗിന്റെ സെൻസറിൽ യൂസ് ചെയ്തിട്ട് we can create or recreate a 3-dimensional picture. Comes in photogrammetry. This is the case of buildings. Also, not just buildings, it can be also used for understanding mapping. Contour mapping na paranjale elevation varathile. Ella bhoomide ella sthalam same height allallo from mean sea level. Some areas are higher, some are lower. Elevation de study cheyyane, which is called as digital elevation modeling. Elevation de mapping cheyyana what you say, contour mapping. Okay, so you can do like this or you can do like this. This is a satellite data. Satellite data, this is an interpretation key develop cheyidittu vena ingante satellite data analyze cheyan. But this more or less looks like a photograph. That's the difference. You can also analyze the transportation network, road and rail network, etc. I think I am running short of time. I'll move ahead. Okay, it can be also used for disaster monitoring. This is a view of the most famous earthquake of Gujarat, which happened. Okay, in Bhuj, the epicenter was Bhuj. Before the earthquake, this was the scenario. After the earthquake, this is a scenario. You can't see anything. Everything is in the rubble. So satellite based remote sensing can be used also for disaster monitoring. Not just earthquake, it can also be used for cyclone mapping, tsunami effect, all such things. Earthquake can be used also. This is another regarding application of remote sensing in ocean color monitoring. Okay, OCM. Okay, you can, this is the off coast of Gujarat coast. Algal blooms can be analyzed based upon the chlorophyll A content. Okay, this is by a specific satellite sensor, OCM. Also, you can understand about water resource management. This is the mouth of river Ganga. Okay, how each tributaries and channels are going, what is the trail or what is the drainage pattern of every single river is very important. Why drainage pattern? Understanding drainage pattern is so much important. If you remember 2 years back when Kerala was suffering with the floods, it was told that if the Pamba river basin is still further rain will happen, then Pamba will change its course. Means pattern, and then flow the drainage pattern of the change. So river over the years they do change their drainage pattern. Understanding the drainage pattern is very important. Why? Because ഒരു സ്ഥലത്ത് ഒരു tributary, for example some internal tributary like this, ഇത് കാണാമല്ലോ, അവിടെ ചിലപ്പോൾ വെള്ളം കാണത്തില്ലായിരിക്കും, വെള്ളത്തിന് ഒഴുക്ക് കാണത്തില്ലായിരിക്കും. You cannot see water over here. But when we develop a town or a city, you should take into consideration what is a natural drainage pattern of any river or a stream. Because what will happen, you will go and construct a big shopping mall, or you will construct an aerodrome, or you will construct a overhead bridge on the natural tributary of a river. And obviously, when this river will flood, everything will be inundated. So understanding the drainage pattern is also very, very important. So I'll come to I'm towards the conclusion of the towards the conclusion of the remote sensing. Remote sensing as a technique can be used in various applications. I have just mentioned 10 applications of remote sensing. There are another 50 applications of remote sensing. You can even know where are the fishes in the sea. You can understand n number of how is the soil pattern, what is the soil drainage pattern, what is the soil moisture level. അങ്ങനെ ഒത്തിരി കാര്യങ്ങൾ remote sensing വഴി പറയാൻ പറ്റും. Okay, now what is we can study, for example, I talked about understanding forestry. We can do the same thing by going to the forest and studying it. There is no need for doing remote sensing. We can think like that. But remote sensing gives a synoptic view. What do you mean by synoptic view? Means a bird's eye view. Anything when you look from the above the ground, it gives a clearer picture of the entire terrain. And also it works on different scales. Sir നേരത്തെ introductory remark പറഞ്ഞു. അതുകൂടാതെ I talked about the remote sensing. There are some satellites, some sensors which is having a resolution of 1 meter. There is some sensors which is having a resolution of 1 kilometer. So if you want to understand what is the movement of a cyclone, obviously you will need a resolution of 1 kilometer. But if you want to understand in this orchard of trees, which are diseased trees and which are non-diseased trees, obviously you will need a remote sensing sensor which is having 1 meter resolution. It is considered, so that is an advantage of remote sensing. It is more cheaper. Cheaper means NRSA, if you look for a satellite data, it is not cheap. You will have to spend thousands of rupees for that. But it is cheaper in the terms that manually, physically you go to field. For example, if I had to understand the forest of an entire district, which I had mentioned in the case study, I will need to spend thousands of rupees, and in comparison to that, remote sensing is cheaper. Okay, it is faster. You can do it very fast. You can analyze the data. Once you have made a 1 year data, next year data will be more easily updated, and hence it is faster. Single image can be analyzed and interpreted for different purposes and application. I told that the satellite data is the same, but it can be the same. That satellite data can be used by a botanist, can be used by a zoologist, can be used by geologist, can be used by landscaper, can be used by hydrologist. Anybody can use the same data. Okay. Then repetitive coverage allows monitoring of, sorry for the repetition of the word, allows monitoring of dynamic themes. Okay, so because when I talked about the satellite data, I talked about repeativity. Repeativity means temporal resolution. That means after how many days the satellite will come to the same spot. There are some satellites data which is coming the same spot after 24 days. There are also satellites which are coming to the same spot within 1 day. So if you want to study about forest fires, or you want to analyze the forest fire, you cannot rely on a satellite data which will give you a data after 24 days. Obviously, you will need a satellite data which will give a data within next 24 hours. Okay, so based upon the need, you have to select your satellite, you have to select your sensor, your bands, etc. There are varied application. Remote sensing as a technique is a very, very vast topic. But in this 1 hour time which I was given, I have tried to give an overview what is this technology, satellite-based technology is all about. And people like botanists like us, definitely you should enter into this field of satellite-based remote sensing, so that it will be a boom for others. So with this, I conclude. Thank you all. Thank you to all the organizers for giving me this opportunity to have a scientific discussion with all those who are present in this online platform. Thank you all once again.
Now, the session is open for discussion. Participants can raise your questions and clarify your doubts either by unmuting or posting it in the chat box.
Thank you, Leena. It was indeed a great presentation, the most simplest way you could move. Requesting the students to ask questions and clarify doubts.
Yes.
So come forward and ask questions.
Feel free to ask anything which you wish. If it is in my jurisdiction, definitely I'll answer. Malayalathil Manayalam ചോദിക്കാം.
Leena miss, excuse me. I'm Stephen here.
Yes, sir. Yes, sir. Please, sir.
I just want to ask you one thing actually. Whether we can map an individual tree in a forest. I mean, if you want to individual tree, that means suppose the tree Kullenia exhalata. So in a forest, how many Kullenia exhalata is there in that particular vegetation? Something like that. Whether we can do that thing.
Yes, sir. Definitely, we can do it. As I talked about earlier, if you are restricting your discussion about a particular tree or a particular species, okay, and there is something called as a radiometer. For example, it is a recording device. You can capture the spectral signature of a particular tree.
Okay.
And you will get a DN value. DN value is a digital number value, and that number is the one which will, once we take the satellite data, we will tell the satellite data that just map the one with this DN number. So no two objects will have the same DN numbers. So you can analyze even a single tree or a single tree plant species. In addition to that, there is another data which is called as a hyperspectral data. You can use the this is all which is having a larger resolution, but hyperspectral data using which is working on specific, very narrow spectral range. That data can be utilized even to understand even a single species, or even map that single species, or understanding it overall in a large range wherever that single species is growing. Sir, I would, as you just asked about it, one thing which botany students would like to know is, for example, there was a scheme that to understand India മൊത്തത്തിൽ എത്രയും paddy cultivation ഉണ്ട്. Okay, paddy എന്ന് പറഞ്ഞ cultivation ഒരു major crop ആയതുകൊണ്ട് cultivation എത്ര ഉണ്ടെന്ന് ചോദിച്ചപ്പോൾ, so they were able to understand paddy cultivation, but they want to separate basmati rice with other traditional rices. Now, basmati is having the same spectral signature as any other paddy variety because both are paddy. Now, it was a big task for the scientist. From there, a botany scientist came into picture, and very easily the scientist brought a solution. See, mapping paddy, as I said earlier, you take the spectral signature of paddy and tell the satellite data to map it based upon this particular signature. So mapping will be done. So that is fine. Then they took many dates data. Now basmati is such a rice that it has a longer growing season as compared to other traditional rices. So the ones which are harvested are traditional paddy, and those which are still growing, they are basmati. Angana or simple common sense use ചെയ്തിട്ട് പാഡിയുടെ അകത്തുനിന്ന് ബാസ്മതിയും നോർമൽ ട്രഡീഷണൽ വെറൈറ്റീസിനെ സെപ്പറേറ്റ് ചെയ്യാൻ പറ്റും. So you need to use little common sense also for remote sensing, and for that botanists are very important. I hope I answered your question, sir.
Okay, thank you, miss.
Thank you, sir.
Good afternoon, ma'am.
Yes, give the question.
മാം ഇപ്പൊ ചോദിച്ച ക്വസ്റ്റിനോട്ട് റിലേറ്റഡ് ആയിട്ടുള്ള ഒരു ഡൗട്ടാണ് മാം. അതായത് ഇപ്പൊ ഒരു സിംഗിൾ സ്പീഷീസിനെ നമ്മൾ ലൊക്കേറ്റ് ചെയ്യുന്ന ഒരു കേസ്. ഓക്കെ മാം, അപ്പൊ ഇപ്പൊ ഒരു സെയിം സ്പീഷീസ് തന്നെ ഡിസീസ്ഡ് കണ്ടീഷനോ സ്ട്രെസ്ഡ് ആയിട്ടുള്ള കണ്ടീഷനിലോ ആണ് ഉള്ളതെന്നുണ്ടെങ്കിൽ സ്പെക്ട്രത്തിന് എന്തെങ്കിലും വേരിയേഷൻസ് ഉണ്ടാവോ?
Very good question. Okay, very apt. I missed to talk inside in between.
Yeah.
If you remember, spectral signature pattern share ചെയ്തപ്പോൾ അതിനകത്ത് വെജിറ്റേഷന്റെ സ്പെക്ട്രൽ സിഗ്നേച്ചർ ഷെയർ ചെയ്തപ്പോൾ 3 പാരാമീറ്റേഴ്സ് ആയിരുന്നു which decide the spectral signature. One is the leaf pigment, cell structure and the water content. മൂന്ന് ആസ്പെക്ട് ഒരു വെജിറ്റേഷന്റെ സ്പെക്ട്രൽ സിഗ്നേച്ചർ ഡിസൈഡ് ചെയ്യുന്നത്. Now, a plant, if it is under stress or if it is under pathogenic attack, in the fungal infection ആണെങ്കിലോ അല്ലെങ്കിൽ പാത്തോജനിക് അറ്റാക്ക് ആണെങ്കിലോ ഒരു ന്യൂമറ്റോഡ് അറ്റാക്ക് ആണെങ്കിലോ അതിന്റെ വാട്ടർ കണ്ടന്റ് ചേഞ്ച് ആവും. നമുക്ക് പനി വരുമ്പോൾ നമ്മുടെ ടെമ്പറേച്ചർ കൂടുന്ന പോലെ തന്നെ ഇറ്റ്സ് വാട്ടർ കണ്ടന്റ് ചേഞ്ചസ്. because of water content change, the spectral diffraction pattern changes. To that extent, if intracellular fungal infection ആണെങ്കിൽ intracellular mycelium grow ആവുന്നുണ്ട്. Intracellular mycelium മൊത്തത്തിലകത്ത് grow ആയെങ്കിൽ second point, that is cell structure vary ആവുന്നു. Internal cell structure vary ആവുന്നു. Okay?
Yes, ma'am.
Because of which the spectral significance is complete. Okay? And
Yes, ma'am.
in a particular tree, you can pinpoint which are the trees which are diseased and which are the trees which are non-diseased. To that extent, morphological symptoms കാണുന്ന മുമ്പ് തന്നെ നമുക്ക് അതിന്റെ സ്പെക്ട്രൽ സിഗ്നേച്ചർ വഴി ഡിഫറൻഷിയേറ്റ് ചെയ്യാം.
Okay, ma'am.
ഓക്കെ കിട്ടും.
ഓക്കെ മാം. അപ്പൊ നമ്മളിപ്പോ ഡാറ്റ എടുക്കുമ്പോ തന്നെ നമ്മപ്പോ അങ്ങനെ ആ ഒരു കാറ്റഗറിയും കൂടി കൺസിഡർ ചെയ്തിട്ട് വേണം അല്ലെ ടോട്ടൽ നമ്മ കാൽക്കുലേറ്റ് ചെയ്യാൻ വേണ്ടിയിട്ട്?
മാംഗോ ഓർച്ചിഡ് ഉണ്ട്, നോർത്തിൽ ഒരുപാട് മാംഗോ കൾട്ടിവേഷൻ ഉണ്ടല്ലോ, അതിന്റെ ആയിരുന്നു ഒരു സ്റ്റഡി. ഓക്കെ, അപ്പം ഒരു മാംഗോ ഓർച്ചിഡ് ഒരു ഫീൽഡിൽ ഒരു 300 മരങ്ങളുണ്ട്. അപ്പൊ ചില മരങ്ങളുടെ സ്പെക്ട്രൽ സിഗ്നേച്ചർ വ്യത്യാസമായിട്ട് കാണുന്നു, ചില മരങ്ങളുടെ സ്പെക്ട്രൽ സിഗ്നേച്ചർ വ്യത്യാസമായിട്ട് കാണുന്നു. 2 കാറ്റഗറി ആയിട്ട് കാണുന്നു. എന്നാൽ ചെടികളെ മരത്തിൽ കണ്ട ഒരു വ്യത്യാസവും ഇല്ല. പിന്നീട് ദാറ്റ് ആ സ്പെക്ട്രൽ സിഗ്നേച്ചർ അല്ലെങ്കിൽ ടോൺ ആൻഡ് കളറിൽ വന്ന വേരിയേഷൻ ബിക്കോസ് ഓൾ ദോസ് ട്രീസ് വർ ഡിസീസ്ഡ്. വന്നു. Okay, so you can
Okay, thank you, ma'am.
Okay.
Thank you, ma'am.
Yes, students, anything else?
Excuse me, ma'am.
Yes, Neha.
Ma'am, ഈ bathymetric mapping എല്ലാം എങ്ങനെയാണ് മാം ചെയ്യുക?
I could not get you.
Bathymetric
കേട്ടില്ല മോളെ.
bathymetric
Can you type?
bathymetric mapping ചെയ്യുന്നത്?
I am not getting your words.
Yes, Neha, just put it in the chat box.
Okay, sir.
I have not received Sneha.
Bathymetric.
Can you? Bathymetric map. Mola, what do you mean by bathymetric mapping?
Like to know the depth of the sea and oceans, like.
Okay. In that terms, yes. Sensors. See, what all I was talking about is all related to passive remote sensing. Passive remote sensing means the sensor is not producing any radiations. Okay, the sensor is passive. What all solar radiations are produced are solar radiations earthy വീണിട്ട് ആ physical chemical properties വരുന്ന വ്യത്യാസം reflected radiations അങ്ങ് പിടിച്ചെടുക്കും. But there are certain active sensors. Okay, active sensors are the one which will produce the radiations of its own interest. പറഞ്ഞ radiation active sensor radiation produce ചെയ്യുന്നു, earthലോട്ട് ആ radiation കൊണ്ട് വീഴുന്നു, reflected radiations that will be captured by the sensor back again. അപ്പം ഈ bathymetric mapping depth understanding ചെയ്യുന്നതിന്റെ for that you will need an active sensor. Okay, and that is that leader sensing, LIDER, leader sensing and all, LIDAR sensing and all are used for such mapping the depth to a certain distance. They can do it. That is also used for understanding the location of fish, the school of fish in the sea. About fishing, mechanized fishing, that becomes easier. Is
Okay,
it
ma'am.
clear now?
Yes, ma'am.
Okay.
Thank you, ma'am.
Okay, Sneha.
Any more questions?
മിസ് നമുക്ക് ഈ GA സോഫ്റ്റ്വെയർ ഫ്രീ സോഫ്റ്റ്വെയർ ഒക്കെ അവൈലബിൾ ആണോ? ഇനി അത്
നമുക്ക് പല റിമോട്ട് സെൻസിങ് സാറ്റലൈറ്റ്സ് ഡേറ്റ ഫ്രീ ആയിട്ട് കിട്ടാറുണ്ട്. മോഡിസ് ഡേറ്റ, ഗ്ലോവിസ് എന്ന് പറഞ്ഞ ഡേറ്റാസ് ഒക്കെ ഉണ്ട്. GIS സോഫ്റ്റ്വെയർസ് ആർ ബേസിക്കലി ഓൾ പെയ്ഡ് സോഫ്റ്റ്വെയർസ്. ഒരു പ്രൈവസി ഇഷ്യൂ ഉണ്ട്. പൈറേറ്റഡ് സോഫ്റ്റ്വെയർസ് ആകുമ്പോൾ നമുക്ക് അതിന്റെ പ്രശ്നങ്ങളുണ്ട്. അല്ലെങ്കിൽ ഓൾ അതർ സോഫ്റ്റ്വെയർസ് വിച്ച് ഗീവ്സ് യു അക്യുറസി, വേറെ സോഫ്റ്റ്വെയർസ് ഉണ്ട്. പക്ഷെ സാറ് റിമോട്ട് സെൻസിന്റെ ഒരു ബേസിക് കാര്യം എന്ന് പറഞ്ഞാൽ we are able to study everything sitting inside a lab. For example, ഞാനിപ്പോ ഫോറസ്റ്റ് ഡെൻസിറ്റി ക്ലാസിഫിക്കേഷൻ ചെയ്ത ഞാൻ ഫോറസ്റ്റിൽ പോയില്ല, ഞാൻ ലാബിൽ ഇരുന്ന് തന്നെ ചെയ്തു. അപ്പൊ അങ്ങനത്തെ ഒരു സ്റ്റഡി ചെയ്യുമ്പോൾ അതിന്റെ ജിയോ റെഫറൻസിങ് ഇസ് എ മേജർ തിങ്. പിന്നെ ഒരു 10 സെന്റിമീറ്റേഴ്സിന്റെ കാട്ടിലും കൂടുതൽ വേരിയേഷൻ വരാൻ പാടില്ല. നമ്മൾ യൂസ് ചെയ്യുമ്പോൾ ജിയോ റെഫറൻസിങ് പറ്റത്തില്ല. അപ്പൊ എക്സാക്ട് ലൊക്കേഷൻ ഓൺ ദ ഗ്രൗണ്ടും നമുക്ക് കിട്ടുന്ന ലൊക്കേഷനും രണ്ടായിരിക്കും. അതുകൊണ്ട് നമ്മൾ ഉദ്ദേശിക്കുന്ന തെറ്റിപ്പോകും. That is the problem.
Okay. MSc students, you can ask any questions.
Yes, please. Anybody has any doubts? ആർക്ക് എന്താ വേണമെങ്കിലും ചോദിക്കാം. എനിക്ക് അറിയാവുന്നതാണെങ്കിൽ ഡെഫിനറ്റ്ലി പറയാം.
I guess there are no more questions. Thank you, ma'am. Thank you for sharing your immense knowledge with us. Your presentation was so simple and highly informative. Thank you so much, ma'am. I humbly invite Dr. Jasila Fatima, Assistant Professor, Department of Botany, Maharaja's College, to deliver the word of thanks.
Thank you, Sneha. I hope I'm audible.
Yes.
Yes, ma'am.
So it has been a very pleasant afternoon today, hearing from two subject experts in the topic on remote sensing and image processing, something which we are not so very familiar with, but at the same time, we have lots of applications of this technology in our day-to-day life. I could say that, considering the fact that the technique is being widely used for disaster management and mitigation, as well as all the different developmental activities of the country. So this has been a very nice presentation by Dr. Leena, and the stage set well by Dr. Shaneed by introducing all the different types of satellites which are being used for remote sensing, as well as the major role that ISRO is playing to bring ahead or to foster ahead our country in this area of technology and helping the country to prosper better. So coming on to my duty to present vote of thanks, let me first start with putting on record my gratitude on behalf of the Department of Botany, IQAC, as well as Kerala Academy of Sciences for all the motivation and support. Our principal, Dr. Matthew George, then for giving us an opportunity to collaborate with Kerala Academy of Sciences. May I put on record our sincere gratitude to Dr. G.M. Nair sir, who is the president of Kerala Academy of Sciences. Then we were fortunate enough to have Dr. Shaneet M., the vice president of CAS, with us to have a curtain raiser on this topic. And so very thankful to you, sir, for being with us. And he has spent almost 2 hours with us throughout the time he was sitting. And thank you so much, despite being a very busy person. Thank you for being with us and motivating us. Then coming on to all the technical sides, Dr. Santosh, the IQAC coordinator of the college, he is behind us motivating to do all these different kinds of academic activities. And while the meet was going on in this Google Meet platform, parallelly we were also live streaming. And it is Dr. Santosh who helps us with all those kind of technical aspects, and sincere gratitude to him. And the center point of today's whole program, the resource person, Dr. Leena. She's a very good friend of mine, and I'm very, very happy that she could speak about all the different kinds of remote sensing, how it is being done. Truly speaking, mostly it will go beyond above our heads, but she took a mode of presenting the whole thing through a case study, which I hope the students would have easily correlated with, and how exactly these techniques are being used or put to use in a very simple term, and using Malayalam in between her presentation. That also added the way in which the things were transacted, and I'm hoping that the students would have benefited out of this. And if at all they have any doubts regarding all these, she is a person who is available. So students, you can even contact her after this meet as well if you have any more doubts which you were not wishing to ask here. So thank you so much, Dr. Leena, for joining us today. And truly speaking, it was a very short notice that I had given her, but she came up and she accepted this invitation to be a resource person. And I think you have done justice to the topic that you have taken up. Thank you, Leena, from all of us here, representing all the students, the faculties, and everyone here present. Thank you so much. Then I would like to put on record my special thanks to the General Secretary of Kerala Academy of Sciences, Dr. Ramesh. He has been a key player with us throughout all the 4 lectures that we have conducted. He was here with us right from the start till the end, giving us all the directions of what to do and what not to do and how to do. Thank you, Dr. Ramesh, for being there for us. Thank you. Then our HOD, Sir Thomas Anthony, sir, he's a person whom you can approach anytime for motivating us and helping us with all the different small issues and reviews that we come across, solving the problems. Thank you, sir. Just for formality, I need not thank you, but still you're part of this team. Then all the teaching staff, non-teaching staff, the students, our strength. Then all the different participants, all the different dignitaries from CAS, some of the dignitaries from CAS has joined us. Then all the teaching staff and students from various departments have joined. And as I said, we had viewers in the live stream as well. And I should put a special thanks to Dr. Sham. He's a part of our family. He has helped us with live streaming. Thank you, Sham. And to Stephen, sir, my co-coordinator. Shanti for the pleasant introductions, Sneha for the comparing, and Sri Lakshmi for the prayer, and everyone, all my colleagues and students. Thank you once again for making this a pleasant evening. I hope I'm not missed out anyone. So thank you everyone for joining us, and we will again meet on December 31 with another talk, the final one in this series of Professor Rajamma Memorial Lecture Series. And on that day, we will have Dr. Ramesh as our resource person. So thank you once again. Thanks for joining.
Thank you, ma'am. With this, we come to the end of today's session of the lecture series, and I thank each one of your active participation. Thank you all for joining. Thank you.
Thank you all.
Thank you, Shanit sir.
Bye.